You're all welcome in your maths, and I got a new problem. Today we are going to prove why irrational numbers are a real number. So let's go. So before proving this, let's understand some basics. So this is our real number line, or you simply call it a number line. So why it is real number line? Because you can plot any real number in this line, and no real number is excluded or outside of this line. So I can plot rational number, but how can I plot irrational number here? Today we will going to discuss this. Now the question arises, is there any other numbers instead of real number? So yes, that is imaginary number. So here this line is imaginary number line, and you can't plot the imaginary numbers like iota, 2 iota, so on in the real number line. Therefore this is a separate number line or separate coordinate axis. Therefore we will discuss this in the separate video because this is a separate topic. So now let's understand how can we plot irrational number. So first of all, let's consider a number line and take 1 unit length in this, and also a perpendicular 1 unit length. Okay, so when you connect this is 90 degrees. So when you connect this from Pythagoras theorem, this is root 2, and when you draw a circle like this, so the radius is root 2 and this length is also radius, which is root 2. So you can plot root 2 like this. And for plotting root 3, again draw a perpendicular 1 unit length, and this from Pythagoras theorem becomes root 3, and when you draw a circle of root 3 radius, this length becomes root 3. So this is also root 3. Okay, and likewise you can draw 1 unit perpendicular length and can plot root 4 irrational number in the number line, which is here. And likewise you can draw again 1 unit perpendicular length and can plot root 5 irrational number, and again 1 unit, and again root 6, again root 7, and like that you can plot any irrational number. But the problem is, can you plot this irrational number? It becomes too large and too big to solve. Can you plot this? So how can you plot these all? So the second method is for that. So for that, let's draw a semicircle and consider this length from here to here of 1 unit length, and assume this to be x. And when you draw a perpendicular length from here, so first of all this is center of the circle, and this length becomes root of x, perpendicular length. Now how can you plot this on the number line? So for that, consider a number line. This is 0, and draw a semicircle like this. This is 1 unit, this is x, and this perpendicular length becomes root of x. So draw a circle like this, and this is root of x, so this length becomes also root of x. And likewise you can plot any irrational number in the number line. So now let us prove this, why this is root of x. So for proving this, let's join these two lines, and now this whole length is x plus 1, which is diameter. So x plus 1 by 2 is basically radius of the circle. So this length is what? Basically this is x plus 1 by 2. And now this length is basically from here to here, this length is basically radius. This is 1. So this length becomes radius minus 1. That is x plus 1 by 2 minus 1, which is x minus 1 by 2. We got 2 lines length, so we can calculate the third length from Pythagoras theorem, which is x plus 1 by 2 whole square is equal to x minus 1 by 2 whole square plus p square. And from here you can calculate the p square is equals to x, and from here I get p is equals to under root of x. And you must thinking that why p is not equals to plus minus under root of x, because negative is rejected, because the length can never be negative. And as I have told you, you can plot any irrational number like that only by putting the x value. Hopefully you get it. So don't forget to like and subscribe.